Okay, so good afternoon, everybody. Many thanks for joining us and welcome to our webinar on smart tools for pest and disease management in protected edible crops. Although I think some of what will be said will also be relevant to outdoor crops. My name's Rosemary Collier. I'm from the University of Warwick, and the University of Warwick are partners, or one of the partners, in the Smart Protect thematic network, which is a Horizon 2020 European funded project. So just a small amount about Smart Protect. So it's coordinated by Inagro in Belgium, and I see that Sabine, the coordinator, has joined us this afternoon. We're focusing on cross-regional knowledge sharing of smart IPM solutions for vegetable farmers and advisors. The network has 15 partners, and in short, we've been identifying smart approaches to IPM in vegetable crops. And you can find out more about the network on our website, the link's shown there. So the approaches that we've identified include methods of application of pesticides, biocontrols, diagnostics and detection techniques, monitoring techniques, and decision support systems, and other approaches as well. We've been focusing on technology readiness level 9, which is an actual system proven in an operational environment. So a lot of the, or most of the techniques and tools we've been focusing on are available for growers and advisors to purchase. However, within the project, we're not making specific recommendations or endorsements about products. So you can check out what we've identified on our Smart Protect platform, and the information is available in 12 languages. So without further ado, we'll go on to the content for the afternoon, and we're very fortunate to be able to hear from 3 companies who are involved in the development and commercialization of smart tools for IPM. So we'll start with Ant Surridge from Fargrow, and Ant's going to talk about sensor technology in commercial horticulture, barriers and opportunities. So I'll unshare and hand over to you, Ant.
Great, yeah, I'll just get my slides up too. I think there's so many people, it's going to be quite slow, but just give me a second.
Okay. So again, please could everybody turn off their cameras and microphones if they're not speaking, just to take the pressure off the system a bit.
I think
Yes.
That should be okay now. Have you got it?
See it now. Brilliant. Well done.
Stuff. Panic mode there for a second. Okay, yeah, great. So I'm Ant Surridge. I'm Technical Development Manager at Fargrow. So my role covers quite a broad spectrum of different areas. So everything from kind of the regulatory development of our biopesticides, and also grower trialing of the biopesticides, right through to kind of working with some of the newer innovative technology that we bring to market. Things that we'll touch on slightly later, like remote sensing systems, plant level sensors, and drone technologies. But being the first speaker of the day, I've also got quite a nice opportunity to kind of set a bit of the scene, give some of the kind of key opportunities and barriers that the industry is currently facing, and then also some of the barriers that we see quite a lot with sensor technology, as I imagine there's probably a mix of growers and sensor technology providers on the call, so hopefully giving a bit of context to some of the other speakers' talks after me. Okay, so who are Fargro? So Fargro, I appreciate a lot of you on the call probably won't know who we are, especially if you're joining us from overseas. We're based in the UK, just outside of Brighton. We're a kind of one-stop horticultural shop, but we offer quite a lot of technical solutions. So our kind of domain expertise is in things like biocontrols and biopesticides. So in the UK, we've been working with the biocontrols since 1990 and working with biopesticides since we introduced Serenade in 2009. And the reason I always think that's quite important to mention is those kind of new technologies, bringing them to the market. We're very used to seeing the kind of barriers that growers have had to overcome. And obviously that experience stands us in quite good stead with some of these digital solutions and figuring out how we can take quite interesting technology, whether it's sensors or digital platforms, and put them into growers' hands and actually start getting value from them. But yeah, in recent years, we've been investing a lot of money and time into looking at digital solutions, looking at which ones are at market and developing solutions that are not at market yet, but we think solve certain issues. So in terms of what I'd like to try and cover today, I mentioned it briefly on the previous slide, but looking at some of the key reasons why digital technologies need to come into the industry and some of the problems, the key industry problems that we can solve, what type of systems we're working with to give you a bit of a flavour of some of the sensors that are involved within the Smart Tools projects and some of the sensors that are available to growers. I think all of the sensor systems, apart from one maybe, are quite broadly available around Europe, but I'll mention that when we get on to the sensors. And then also look at a way in which data from these sensor systems can be transferred into actual actionable insights for growers, because probably one of the key barriers that we see at the moment to real widespread uptake of sensor technologies is how do you bridge that gap between a system producing information and graphs and then actually actioning changing an IPM approach or improving the application of certain products. How do you bridge that gap without putting extra work on a grower to have to go and wade through data to make an interpretation? So what are the kind of key opportunities at the moment? Well, opportunities tend to come from challenges, and as an industry, we certainly face a lot of challenges at the moment. So just to touch on a couple of key areas and not stay on them for too long, some of the key areas that are presenting particular opportunities for the development of digital solutions would be things like crop protection. So we're going to see, and we are seeing, a fundamental change in the way that crops are protected. And I think that's beyond a global context as well. We're losing a lot of conventional chemistry and it's often not being replaced, or what it is replaced with is biological controls and biopesticides, which need to be really thought about within an IPM program so that they'll get maximum efficacy. And we know for a fact when these products are used in the correct manner, they can be very efficacious, but it's a very complex and knowledge intensive system to make sure that you're applying the right product at the right time, at the correct life cycle stage of the pest you're looking to control in the right environmental conditions. All of that extra thought and complexity makes it a very difficult decision to make in the moment for a grower when they find an issue. So how can we take some of that complexity out of the hands of the grower, put it in a digital system and feedback in real time to them is what we're interested in. So the biological inputs do often have lower intrinsic efficacy, but if that efficacy is consistent, then we can build on that within the IPM program. So again, looking at how we can make sure that we're using the products at the correct time to get maximum efficacy out of them. Things like labour availability are obviously really pushing forward the digital uptake and using digital tools on farms. So it's obviously difficult to find labour generally, but what's even more difficult is finding skilled labour. So taking some of that skill out of the hands of the workers and putting it into a digital system can enable upskilling of workers, or just having a knowledge base that will speak to less skilled workers can allow them to make more informed decisions. Generally, the demographic of agronomic labour, but generally agronomists around the EU and the UK is an ageing demographic. I think the average age is about 62 for an agronomist around the EU, which is kind of compounded by the fact that horticulture and agriculture generally isn't an industry that necessarily sells itself particularly well to newcomers. So creating digital systems for a kind of digital native generation that will be coming into the industry is very important, both in terms of skilling them up to the level of an experienced agronomist, but also getting them interested in the industry in the first place. And also what's real key potential for these systems isn't necessarily solving any of the challenges, but just some of the value that the systems can bring. So things like creating digital twins, allowing for modelling of what might happen with certain inputs, identification of possible efficiencies and optimization around the farm. So looking at what issues have occurred, what an application process looked like, what the outcome was, and what factors might have meant that you didn't get the desired outcome, or finding reasons why you had a pest and disease infection based off of environmental data sets or hyperspectral image analysis, can all allow you to get that kind of marginal gains philosophy into a growing business where you're looking at making small improvements. And the addition of things like machine learning and artificial intelligence, which we've really seen boom in the last couple of months with things like ChatGPT, can really give us the potential to start looking at how we can create these models specifically for farms, and even more specificity for farms with multiple sites, and create models that are really specific to a certain area. So there's huge value in and of itself, these digital technologies coming online. So to briefly kind of touch on some of the areas that Fargrow are working on at the moment. So we've got quite a broad range of sensor suites that we're working with. So it's kind of everything from remote sensing through to camera systems. So with the remote sensing and IoT devices, something that we're very keen on doing probably a couple of years ago now was showing our growers the value of going from a kind of sensor box that's hung outside of the crop to a remote sensing system that's actually within the canopy, feeling the actual conditions that the pests and diseases will be feeling within the canopy. And you can see in a couple of the images, like the bottom left and then the kind of top right that's just below the kind of tinfoil sleeve, how those sensors sit within the crop and give you a really reflective reading of what the plant is feeling. And that can obviously allow for better prediction of things like pests and diseases, because you're then measuring the conditions they're developing in. If that sensor is hung outside of the crop, then it's going to be at a different humidity and different temperature, and humidity quite often is quite a drastic change. So that's very important in terms of making sure that you're understanding the conditions where pest and disease will be developing, but also where the products will be applied and doing their thing. And I think remote sensing is probably something a lot of people are very familiar with. I mean, it's not a million miles away from the kind of wired sensor systems that control the Priva Hugendorn systems anyway. On the kind of slightly niche side of sensors, the image on the left-hand side in the middle is a electrophysiology sensor from a company called Phytosigns. You can see the one that's wrapped in blue medical tape quite clearly higher up the plant, and then in the crown of that strawberry plant there's another sensor going in, and those two sensors are measuring the electrical impulses that are being sent around the plant. So it's very early stage technology, and the information we're getting back from it is there's a lot of information, and interpreting that and finding ways to make it actionable for growers is what's really important for us at the moment, because if we were to just give that pure data to growers, it'd just be way too much information. But you can detect things like nutrient deficiencies, irregularities in irrigation, plant stress based off of environmental conditions. So what the sensor's really telling you is how much energy the plant is putting into adapting to its environment rather than growing. And obviously the more time it's spent adapting, the less time you're putting towards growing and yield. So it does give some quite interesting information. Top left-hand side is a phytal clip sensor, and then the top right-hand corner is the phytal stem sensor, which are sensors from a company called Tugro. And what those sensors are doing is measuring sap flow and stem diameter. With something like sap flow, it's a really good metric for looking at daily stress. Your sap flow should follow a pretty normal diurnal pattern where you kind of see the plant wake up, working hard in the middle of the day, and then relaxing and recovering into the afternoon, evening. And what we can see with a lot of case studies is that there's certain interventions, whether it's event related or spray timing, that mean that you get an irregular pattern in that diurnal curve. So for example, spraying early in the morning, the plant's often waking up, you're putting the spray on, you're increasing the humidity, which means less transpiration. So all of a sudden you see this increase in activity, big drop off, and then an increase again. And that, from that image, that graph there, you'd think that actually that's not the optimal time to spray. And that kind of information can give you good knowledge on things like nutrient deficiency, because if the plant's not working efficiently and pulling water through itself, then it's not going to have the nutrients properly allocated. And then next to the top left-hand image, the kind of sensor in the hand, that is a hyperspectral camera from a company called Photenics. The bottom right-hand corner as well is a Photenics hyperspectral camera mounted on a boom. And the kind of things we're looking at there is pre-symptomatic detection of pests and diseases. So being able to tell that there's a disease or pest there before the human eye can. We think that's really, really key, because with a lot of the biofungicides especially, there's hyperparasitic modes of action, which essentially mean that you're going to need to apply before the human eye can really see, because it needs to be a very low population pressure of, say, powdery mildew, so low that it would be almost impossible for an agronomist to tell. And then just touching on things like application, we're working quite closely with a range of drone companies to find ways of applying things like macrobiologicals and hopefully things like plant protection products. But there's a few difficulties around the regulatory system at the moment with applying plant protection products through drones, but we hope that that will be addressed relatively soon by CRD and DEFRA. So looking at the clock, it looks like I've not got a huge amount of time left, but I'll just run through a quick example of how we'd give value to growers through data, and rather than just presenting graphs, how you can turn that into actual insight. So we worked on a case study a couple of years ago with a strawberry grower where we were collecting all of their pest and disease data and putting it into a database. What we saw was that the growers started getting a thrips infection. They looked at applying their biological controls once they'd started to see the infection of thrips in the crop. But what we really should have been doing was applying at the first stage that we'd seen thrips coming into the crop based off of the growing degree hour threshold that we built off of their data from when they'd first seen thrips in the crop walk history. The reason they had to wait until they saw thrips was a justification to the finance department to say that we have this out there, we need to invest X amount of thousands in the macrobiological controls to then control it. But because the pest is already there in significant numbers, they're obviously firefighting, which meant that it wasn't as effective as they'd hoped it would be. So what we could do with that was create this widget, which has a growing degree threshold line on it, which counts up towards the point at which they'd first see thrips in their crop, has a now line on it, which then predicts forward the next 10 days based off of the weather data. So that as they start coming up towards that threshold, they can look at placing their order for their macrobiological controls, getting the populations established before infection, so that they can make sure they have good levels of control when that infection does come later, when thrips start taking flight. You can also display that as dashboards so they can see what kind of risk they're at of thrips at a certain time and how likely the different macrobiological controls and biopesticides are to work. So that's kind of taking quite boring remote sensor data, just temperature and humidity data, and turning it into a display, a presentation layer that can actively offer insight, which can then be actioned on farm by the grower, which is obviously how you get real value for them through the sensors. So what are some of the key barriers that we see? Well, what we'd hope with any of the sensor system is that it's a case of installation, training, support, then the grower embraces and has success. But actually, as with any kind of solution that's new to a market, there's a lot of various issues that come up along this process. So I'll just highlight a few rather than go through all of them, but things like requirements of the sensor system, often needing power and Ethernet around a glass house, is possible, but not ideal, especially if it's drawing a lot of has a lot of need for data from the Ethernet and it's drawing quite a lot from it. It can often slow the system down. Ease of use, so how easy it is to install, is quite key. You don't want to present a barrier straight away for the growers. So some of the sensor systems I'd shown previously took about 3-4 hours to install, which isn't ideal. Ease of use, again, in terms of how easy the data is to look at and how easy the platform is to use, and start changing that to get insight from. Whether or not the sensor system is crop or business specific and what kind of value different businesses can get from it, ensuring that it kind of fits into growers' business as usual and you're not asking them to do too much extra work to find that insight. It's quite key. If you're asking them to sit down and analyze graphs, it's not really going to move forward particularly well. And obviously development, which is always kind of key for any of these systems which are quite new to the market. And seeing I'm quite close to the end, I'll move through these relatively quickly, Rosemary. But the kind of ways we can find solutions to that is collaboration between sensor and service providers. There's so many different sensors and services that are coming to the market. Growers are getting a bit frustrated. I've found that one solving one issue, one solving the other issue. None of them are coming together in a centralized fashion to give real farm level value across these different sensor systems. Focusing on providing grower value rather than kind of creating a nice sensor system with interesting analysis. It needs to be not necessarily understandable, but actionable by a grower so that they can actually take that data and turn it into something on their site. Ensuring the solution is adding value and not adding extra work. making sure the system is very plug and play and easy to use, and making sure it's plug and play involves going out and actually asking a grower to install it rather than someone that's full-time employed by the sensor company to go out and do it, because what's plug and play for them is to not plug and play for a grower that's got a million other things to do on a day. And yeah, ensure the system is future-proofed, which kind of links to the collaboration side of things, making sure all these different sensor and solution companies are talking to each other to make sure that there's value across the different services. So I probably had a few too many slides, so I went through some of those quite quickly, but there's loads to talk about in this subject area. Like, there was quite a few sensor systems that I kind of moved over relatively quickly. So if you have any questions or want to get in contact, there's some time for questions at the end, but all of my contact details are up there as well. So if you want to have a chat about any of it in more detail, do let me know.
Brilliant. Thank you very much, Ant. Excellent overview. Do you want to put your contact details in the chat as well? That might make it
yeah, no worries. I'll do that now.
Yeah, fantastic. Right, so now we're going to move on to Boštjan Božić from TrapView, and Boštjan's going to talk about automated pest insect monitoring and forecasting.
Hi everyone, thank you for having me here, to have the opportunity to talk to you. Everything's okay?
Slides looking good, yes, thank you.
Okay, great. Much of my presentation will actually really overlap with Ant's, and I do very much agree with what Ant already explained in the previous slides. The beginning of my presentation is more like, what does smart or automated really mean in pest monitoring? And there are quite a lot of solutions out there claiming, and they are actually automating at least one step of the process of the pest monitoring process. Either is automating the process of collecting the pest data at the beginning, right, with the use of different kind of automated insect traps, either automating the decision-making process, or let's say at least processing of the data that is collected. So that's the middle part of the little graphic here. Or they are automating or supporting the decision-making process by providing this information through monitoring application or using user applications that are usually installed on user devices, mobile devices, or even stationary devices. So what to answer the question, what does smart automated mean? It usually means anything that is taking a little bit of efforts of the grower solars in terms of some activities with pest monitoring. So when and already touched this thing a little bit with one of the slides, is that there's never only a just a device when we're talking about solutions or products or pest monitoring products. It should not be only the device, because device is only a sensor. It's only a means or a tool to collect the data and how this data is collected. And the solution, the whole solution of automated pest monitoring should entitle or should enclose also some services, whether it's this installation services or support services, and provide also some deeper insights into the data collected, which is, in our case, that would be predictive analytics and reports, providing also some, besides only analytics or statistical analysis, there should be some modeling and simulation involved in that as well, if possible. I don't want to bore you with how, or let's say, the most of the technology behind automated pest monitoring solution looks like. but just to give you a brief overview of the blocks, of the building blocks of the solution. So there is a data collection device, or in our case, this would be traps, pest insect traps, collecting the data about the presence of the pests in the fields. And then this data collected by the traps is sent to a central processing unit or to the server infrastructure where this data is processed, and then with the processing and machine learning algorithms, further insights are then distributed to different kind of users through different kind of means, whether it's mobile app, whether there's automated reporting available or notifications. And then the growers can, based on this information, growers can decide better, or at least have they can make better decisions or more informed decisions in terms of crop protection or plant protection operations. One of the things that I would point out when choosing a system is, well, since we are in the market since 2012, actually our first customer comes from the UK. And we've seen quite a lot of solutions coming and going, and some of them even stayed with us. One of the major, I would say, decision factors, or one of the factors that are playing quite an important role, whether the solution or indicator whether the solution is sound in one way or another, is the data that the solution has in possession, for a few reasons. As soon as the company claims that there is some machine learning or artificial intelligence, you should always ask what's the database that the company is working on. And that's quite important, because without good quality data, without quite good historical records, no company can make a lot of good information out of that, or to teach the system. Even with all the powerful, let's say, AI machinery that's very popular recently, if there would not be any data to feed, for example, ChatGPT, there won't be any ChatGPT, right? So the solution is only good as good as the data that is being controlled over that solution. So this is one of the major things to be cautious about when deciding what solution you should decide for. I also want to touch a little bit about how the pest data should be collected. So whether it's pest, you see only the insect traps here. Of course, there are other sensors in use. But no matter what sensor we are talking about, all the data should always be collected automatically. It should be collected frequently, reliably, accurately, and these are, let's say, the four main pillars of the data collection. Any decisions made on very fragmented data, or not frequent or irregularly frequent data, would probably be bad decisions. Also, there is no, how can I express myself? There's no solution that fits all right? And there is, you are probably even, you know even better than myself that there is never one sensor or one type of device or one type of tool even that you can use in all different kind of environments, all different kind of production methods, all different kind of let's say crops, geographies even, etc. Here on the right is just a little example of how diverse a product range should be, for example, for covering just a number of different crops that are shown here on the right side. And we as TrapView, as I'm presenting TrapView, we are mainly specialized on Lepidoptera and Diptera species. Okay, and when deciding for an automated trap, it's always good to have in mind a few things. The first thing would be whether the device is independent in terms of energy source. Most of you are actually in greenhouse environment, which means that some energy source is available there in terms of electricity. Okay, if in open fields, it's really a good idea that no additional electricity source is required by the device that you want to use. And also the quality of the imagery or the quality of the data, how that is collected and how this data is transferred, whether but in terms of in Europe, at least in UK as well, we don't normally see any connectivity issues. So that's really not an issue anymore in the recent years. It's always good that there's some weather sensor, and what is a bit also important is whether the device is robust, whether it's weather resistant, whether it's and whether it's requires or at least minimizes the need for maintenance and repairs. Touching the report section, well, if the reporting provides you with the information based on which you can base your decision, that's already a very good report. And also the personalization or customization of reports that can fit your needs, that can fit your specific needs. That's always a very good thing to have in mind when choosing something over another. The way that what actually the technology can already provide with the use of machine learning or artificial intelligence is what I'm showing here on this slide. Of course, weather is not something that has been just recent, right? Weather forecasting has been around for a while, and although we do provide weather forecasts in our system, we do not, we actually carry them over from the third-party provider because there are companies much better at weather forecast than we are. But what we do pride ourselves in are the forecasts about past population and past development stages. And for some certain pests, TrapView at least is able to process and provide the population, adult population forecasts, which actually means that the system can issue a warning that says whether there is an increased risk that the adult pest population is going to increase or decrease in the following days. Mind saying that that we are mainly focused on Lepidoptera here, right? In Lepidoptera species, the adults are not directly damaging the crops, but their children are, right? But when we know what is the population of the adults, we can then deduct based on the adult population what the development of the let's say early stages like larva or egg stages is going to be like in the following days. And this is exactly what our system does, is that there is also a possibility to forecast past development stages. And it looks something like this, right? I'm not sure whether you see it well enough. It's a bit detailed chart, but on the top of the picture here, do you see my pointer? So here is the number of catches of adult population. And based on the catches of the adult population, the system is projecting or calculating, the algorithms are calculating the stages, the development stages. So if this is adult population, then in a few days, considering also the weather forecast and so on, the majority of population is going to be in X stages here. This is the blue curve here. And later on, eggs will hatch, there will be early stage larvae here, and then the larvae will develop in later stage larvae. With the system, with the ability to provide some simulation of crop protection. So this part here shows what if analysis in case there would be some crop protection applied, and providing some weather forecast to make a better decision, right? We will not go spray if there's some rain predicted in the following days. There is also the service part. I won't take much time here because Ant actually said it much better than I can. I also think that the customer care and the ability of the provider, of the technology provider, to give a full service coming from installation and during through the season support, not just maintenance of the devices, of the physical devices, but also some let's say training and even interpretation of the data. It's something that is quite quite instrumental for the success at the end of the season. So what we see, what are the benefits of using solutions that automated pest monitoring and forecasting solutions, is that definitely there is a possibility to reduce the insecticides application with optimizing the timing of the application and optimization of at least in the open fields. There's also possibility to optimize the geographical optimization, let's call it like that, so that you don't need to spray all the fields at the same time, so that you can better decide where and when to spray at a certain moment. Provides a great opportunity for reduction of the usage of insecticides. And again, with possibility of knowing what is the development stage of the pest also increases the efficiency of the novel biological and organic plant protection products. And using these products also can reduce the residues and improves the food quality and so on. As I mentioned, we already have a lot of experience monitoring some of the pests. Just to show you, to give you a little bit of flavor here, or the taste, a little bit of the taste, how it looks like. The data that we are collecting are actually the first type of the data that we are collecting are images, and we still believe that seeing is believing, and deciding based on the images provides a certain level of security for the users. So seeing what's happening without setting the foot in the field also improves, let's say, the cost efficiency of the operations. So this image here is showing Autographa gamma, one of the pests, and also here is Plutela or diamondback moth. So these are actually images from our traps. Of course, this is just to support. This is just the first part of the analysis, because all these rectangles that are the result of machine vision algorithms are then translated to statistics and to the curves and so on that you saw earlier in the presentation. I'm not sure how much time I got left because I don't see.
I think you've probably run out of time now, Vostyan.
Okay, so I'll just finish it here, and I'll be glad to answer any questions if there are.
Yeah, many thanks. So again, if you put your contact details in the chat.
Yeah, sure.
And then we'll go on to Liam, please. So Liam Harvey from BioBest, he's going to talk about the ecosystem of monitoring tools. Yep, your slides are up there. Thank you.
Okay, brilliant. Yeah, I'm Liam from BioBest. I work in IPM and pollination all over the world, but mainly in those countries listed there. I'll touch a bit on BioBest and what we do. Lots of you already know, but just as a brief reminder, we started as the first producers of bumblebees, and then we progressed, as you can see through there, into taking IPM to a high level with our scouting and monitoring systems that we'll talk about briefly in a moment. I'll skip some of this as it's been touched upon before, but ultimately IPM is knowledge intensive, is dependent on training and advice, and they underpin scouting and the accuracy of the information we receive from scouts. So ultimately scouting is people in time, and it is very, very time intensive. So if we can save some time by digitizing or using high-tech tools, or if we can improve the accuracy by using high-tech tools, we're onto a winner. So we can improve the accuracy by training our scouts. That is very time intensive and resource intensive. And what about if we lose our single scout that we've invested our time and effort into due to sickness, or they leave the company? We lose that objectivity. And it's very important to be objective about the scouting data that we get so we can make important and informed decisions. And then we need to take these decisions in terms of the climate. There's no use taking these decisions on our IPM program in isolation. They need to take into account the humidity, the temperature, as Ant touched upon, in the glasshouse, in the crop, not just as a whole, but in the crop. So where can new tech help? It can help in data collection. We can digitize the human observations, making them objective using sensors, cameras, and automation. And we can use this data to helping our decision making, to improve our decision making and improve the accuracy of our decision making through identification, diagnosis, and the use of predictions through algorithms based on climatic data such as day degrees. And then ultimately, we can also improve the application. We're relying on people for the majority of these applications. There's a few machines that have come out in the last few years, but we're relying on accurate delivery of our products, living insects largely, to the crop. So this needs to be done thoughtfully and accurately, and we can improve this through the use of tech and application machines, which we'll look at later. So the first way we can improve our scouting data is by organising scouting observations. BioBest have crop scanner, and this centralises and visualises our scouting data. We can input observations via the app, which produces basic reports on your phone, or the data you can log in on the web portal and you can see more advanced reports and graphs. And within this, we'll touch on later. I'll cover this again later, but within this, you can see our prediction and of pest and also disease criteria, and where we should scout for those hotspots where we expect those pests to be a problem. So we can automate pest monitoring. Again, this can save us time. We can do this via TrapEye. This is a fully automatic sticky trap count. It's magnetic, it goes on the stanchions or the posts, it's solar powered. It takes an image every day or every 3 days, depending on your setup, and you can access real-time data of your population, pest population in the glasshouse. They actually connect to each other, so we have a digital map of pressure over the greenhouse as well as a graph over time, and we can fully automate our trap counts. The time it takes to change is exactly the same to change a normal trap. You just slide it out of the bracket there and turn it over, and yeah, it's replaced and ready to go. And we can already, I think, identify thrips, leaf miner, whitefly, macrolophus, and Nessie automatically from the images. And we have PetSees. Some of you might have heard about this. It automatically recognises and counts moths. It's based on their wing beat and flight pattern. And we can do this in high wire crops. You can see there, this is actually footage, an image or some footage from a tomato crop. So we can monitor tutor, for example, high in the crop in the evenings, or other species in other crops, like Autographa, for example. The camera uses an LED module to illuminate the insects in the evening, and you can look at real-time data in your app, in your phone. The important thing to say here, there's some image there of the flight you can see. I don't know if you can see that video, but the important thing to say here is that we can actually detect moth species 4 to 6 weeks earlier than we can in pheromone traps. And this is important for our interventions, for our BT applications, for example. If we can get the very first individuals, that very first generation, we can take the peak off of the pest population in the season. So we've looked singly at automatic trap counts. We can improve our trap counts, our accuracy, we can improve labour, we can improve time saving, therefore reducing our labour costs. But what about if we can put all this together? We have sensors for temperature and humidity, and touched upon these as well. But what if we can put this all together? And this is kind of what the Yoco does. This is actual data from a grower of mine in the Czech Republic, and in this machine, it can be retrofitted to any kind of trolley, and we have IPM data, fruit counts, and climate registration. So within this, we have IPM data on pest diseases, we have yield forecasts, we have pest and disease forecasts based on the climatic data, and we have crop registration. So we can look at if there's broken heads, for example, or we can do a virtual crop walk. So if I play this movie quickly. So your agronomist, you've got a problem, you call your agronomist can go online on the web app and actually see in 4K exactly what you're talking about, and also the data that you've collected. So there's a graph there that says a map there, so it says normalized climate maps. So this could be a climate map, so we can see there's a hotspot there. If that was also some high humidity, we could potentially be looking at a pest problem. But if we change that to a pest normalized map, that could be a prediction model, and we can send our scouts, saving time and scouting more efficiently, the areas where we can expect or have already seen pests in the past. So we can base it on historic data or live data, depending on how we want to scout. And at the bottom there, that's the actual image from our fruit count. So we need approximately 4 to 6 weeks of fruit count data from the crop, and then we can predict 2 to 3 weeks in advance of what the yield would be per meter squared. So this is the main thing that growers are interested currently, is getting a really good, accurate count of fruit count. Obviously, as you might expect, and current tolerances suggest we're within 5% limits of real life. And this is just a video of the input for the scouting data. So you'll go down with your trolley, scouting down the rows of a high-tech glasshouse, and you can click on the pest that you see. Often there's images, not just names, and you can put the pressure that you've seen whilst going down the road. No need for pen and paper, a lot more quicker, straightforward. And the OCO itself, the machine, will register exactly where you are in the greenhouse at that time. So this is kind of our all-encompass system for collecting this data, to have prediction models, automated fruit counts, and your IPM data in one place. And then finally, so we will have time for questions, luckily. We can look at application. I say there's a few machines out there now. This is BioBest, it's called Entomatic. It's just to improve the distribution of your beneficials, who are largely reliant on and trusting people to do a good job when they're in the field. So yeah, uniform distribution of mites and insects is important, especially when we're working in large areas. It can save you labour and time. These people could be doing other work in the crop, for example, rather than putting out your beneficials. And I've seen this system retrofitted to a sprayer that was already set up on the farm on the back of a tractor. I've seen it fitted on a trolley that goes along the floor in cut chrysanthemums. So it's really, really adaptable to whatever system the grower is currently using. And that's the end of my presentation.
Great. Many thanks, Liam. And again, could you put your contact details in the chat?
Yeah, sure, no worries.
Great. So has anyone got, there is a question for you in the chat, Liam, but you probably, that's a commercial question, so you might want to answer it separately. So has anybody got any questions that they would like to ask about any of the talks? I think Ant, you answered one question, didn't you, in the chat about vertical farming?
Yeah, I answered in the chat, and I can give a quick summary for anyone that's not looked at the chat. So yeah, the question was kind of just around experiences within vertical farms, and it speaks a bit to what some of the other presenters spoke about, which is that the predictions and advice you can give off those predictions is only ever going to be as good as the environment that the previous data set has been developed in. And obviously vertical farms generally are relatively new, so there's not as much understanding of what the example I've given in the chat of what a good day looks like in a vertical farm compared to what a good day looks like in a glass house, where you have that gradual rise of the sun and then setting of the sun, different cloud patterns and so forth. So the sensors technically will work. It's just understanding and working with the growers to figure out what is the kind of ideal blueprint for the crop, and then how we can use the sensors to follow that blueprint and improve gradually upon it.
Great, thank you. Nico, you had your hand up from the beginning. Do you want to ask a question before I ask Jude to ask hers? No? Okay, Jude, would you like to ask your question?
Yeah, thanks, Rosemary. And this is a question for you. You mentioned predicting thrips in strawberry based on temperatures, using their development rates and so on. Is this just for western flower thrips? Because as you're probably aware, there's lots of other species causing problems in strawberry now, and you may not have the data for all of those.
Yeah.
So were you assuming it was western flower thrips?
Yeah. So it was western flower thrips. It was ID'd. This was about 3 or 4 years ago now. And I think what was probably more important to understand about that example is something that we were quite conscious of at the time was not trying to let perfect be the enemy of the good, because what we were really trying to do was give evidence to the finance department of the business that they needed to invest the money at this stage. So we could show the accumulation of day degrees. They knew they were going to get thrips because it's a polytunnel strawberry site that's regularly had issues with thrips. So we knew it was going to come, but they were having to wait and then essentially take leaves in and take thrip samples in from the field to the finance team and say, look, here's the issue. Can you now release the money for us to buy it? So we were kind of helping them with that to actually give some data as to what was likely to happen, so the finance team could have some confidence. But no, it would have just been for western flower thrips on that farm. So obviously there's, if we're looking at all the different types of thrips, there'll obviously be a range of species, but also different environmental around the site factors that would matter, like harvest, for example. We know we'd see an increase in count at that time and probably a bit of crop damage, but then it would drop off later on. So yeah, there's all kinds of different species specific elements that need to go into the prediction models, and I think it's probably key for growers is picking the ones that are obviously most economically damaging, but then being aware of the newer species like with our ornamental crops, things like Thripsitosis, and knowing if the model's not quite right and they are spotting something, then maybe that's it and we need to change the bios as well.
Okay, thanks, Ant.
Great, thank you. So any more questions before we finish? Of course you can contact the speakers individually if you want to follow anything up. Just also to say that I have applied for basis points. They've acknowledged they've got it, and yeah, I know some of you have sent me your details already, so if anybody else wants to, please do so, and I'll let you know what the points are, etc., when I hear back from basis. So right, so it looks like no more questions. So can I say a huge thank you to the 3 speakers, to Ant, Bostjan and Liam. I mean, you've really given us a great overview of all the types of technology that's available, and obviously, yeah, there are opportunities for everybody to follow anything up that they're interested in. So I'll call it a day now, and thank you all for joining us.